So just now we have seen the influence of autonomic nervous system, both sympathetic and parasympathetic pathways, on the action potential of specialized myocardial cell. So there we have taken the example of SA nodal cell. So SA nodal cell, the specialized function of SA nodal cell was automaticity. And under the influence of adrenergic system, under adrenergic influence, what happened? The cell had increased its automaticity, which means there is increase in heart rate, and this is what we call as positive chronotropic effect. Now, under the influence of cholinergic system, what we have just seen is that the SA nodal cell has decreased its automaticity, which means there is decrease in heart rate, and which is negative chronotropic effect. Now, another specialized tissue which we usually explain along with SA nodal tissue is AV nodal tissue. The only difference what we will have in AV nodal tissue, in contrast to what we have in SA nodal tissue, is that the property of AV nodal tissue is conductivity. So here, in place of automaticity, we have conductivity, and under the influence of adrenergic system, the AV nodal cell will be increasing the conductivity, and which is what we call as positive dromotropic effect. The speed of conductivity will be increased, and under cholinergic influence, the mechanism is as same as what we have described for SA node. So under cholinergic influence, the AV node will have decreased conductivity. The rate of conduction will be slowed down, which is what we call as negative dromotropic effect. Now, the last one what we have is contractile myocardial. So let us see what influence the contractile myocardial tissue will have under the influence of sympathetic and parasympathetic stimulus. So we have already seen how the action potential of specialized myocardial cells are influenced by the autonomic nervous system, signals from sympathetic and parasympathetic pathways. Now we also need to see how the autonomic nervous system influences the action potential in a contractile myocardial cell. So we know the specialized cells are rich in both sympathetic as well as parasympathetic receptors. Those are the beta-1 adrenergic receptors and M2 muscarinic receptors. At the same time, the contractile myocardial cell, especially ventricular myocardial cell, are devoid of the M2 muscarinic receptors, but instead what it has in abundance is the beta-1 adrenergic receptors. So to start with, we know the action potential curve which is there in a contractile myocardial cell. We understand that the resting membrane potential is minus 90 millivolts, and when the cell is stimulated, because this is a contractile myocardial cell, it does not have the property of prepotential or automaticity. It requires stimulation from an adjacent cell. So when cations are loaded, it gets stimulated. The resting membrane potential rises from minus 90 millivolts to minus 70 millivolts, which will result in opening of the voltage gated sodium channels, so that phase 0 depolarization of the cell results. And then we have immediate closure of sodium channels and opening of potassium channels, resulting in a slight dip in the action potential, followed by opening of calcium channels, and we have balance of the efflux of potassium and influx of calcium, which will result in no change in the net voltage, which will result in the plateau phase of action potential, and finally the calcium channel closes, the potassium efflux continues, and the cell repolarizes back to the resting membrane potential. Now, and it remains in the resting state. Now we have the sodium calcium exchangers and the sodium potassium ATPase who are working to establish or restabilize the cell with its electrolyte properties, and it is waiting with its resting membrane potential of minus 90 millivolts to the next impulse to come and excite this particular cell. As the next impulse comes, we know how it is transmitted to the next structure or the next segment of the cell. We have a second wave of depolarization and repolarization following. Now what we are going to see is how the autonomic nervous system is influencing the contractile myocardial cell. And under autonomic nervous system, it is only the beta-1 adrenergic receptors is involved. We don't have M2 muscarinic receptors in ventricular myocardial cells. So here, as we have explained previously, for the SA nodal cell, the mechanism is quite same. Under the influence of the adrenergic neurotransmitters, norepinephrine or the circulating catecholamine, which is epinephrine, the extracellular component of the beta receptor will be stimulated, which will result in the attachment of the G stimulatory protein to the intracellular component of the beta-1 receptor, and as it gets activated, it absorbs a high energy GTP molecule and releases a low energy GDP molecule, and the alpha component of the G stimulatory protein will activate the adenylyl cyclase, and the adenylyl cyclase will help convert ATP to CAMP, and the CAMP will further activate protein kinase A, and with the action of protein kinase A, we have opening of calcium channels and the cell will get loaded with cations. Now, just imagine in the resting phase, this is phase 4, the resting phase of the cell. So what are the things which are active in the phase 4? Here we have the sodium potassium ATPases, which is throwing out sodium and gaining in potassium. So this channel is functional, and we have sodium channels here, but these sodium channels in resting phase are not functional in the contractile myocardial cells, but we have leaky potassium channels which results in the efflux of potassium, which sets the resting membrane potential to minus 90 millivolts. Now just imagine the cell is set at a rate of minus 90 millivolt with resting membrane potential, and that is in phase 4, and this particular cell is waiting to get excited when there is entry of cations from the surrounding cells. So it is waiting with its open gap junctions for the entry of cations to get excited. The stage is set for the action potential. The resting membrane potential through all these actions has been set at minus 90 millivolt. But before a stimulus comes from outside, before the cation is loaded from outside as a part of conduction, we have the sympathetic pathway being activated. And under the influence of sympathetic pathways, the calcium channels are opening and the cell is loaded with cations before we are expecting a stimulus. So this is where we are expecting a stimulus from the adjacent cell, but because in the resting phase, because of the adrenergic pathway, the calcium channels are open, and under the influence of calcium channels, the cell is loaded with cation, and because it is loaded with cation, slowly it increases its threshold, its resting membrane potential, and touches the threshold. It increases its resting membrane potential and touches the threshold. And as it touches the threshold, it throws out another wave of action potential. Now this one in the pink color is an extra contraction, an extra action potential, which will result in an extra systole. Now this is not under the influence of any excitation, any conduction from outside the cell, but this has happened because of the sympathetic pathway. So the cell has undergone depolarization before the expected time. So this is what we call as triggered activity in contractile myocardial cell. And this is what we call as positive bathmotropic effect. Which is the ability of the cell to respond to a stimulus increases. The ability of a cell to respond to stimulus increases, and here, before the expected time of the action potential, the cell has generated its own action potential under the influence of sympathetic pathway. This is what we call as triggered activity. We call it bathmotropic effect. So this is one effect what contractile myocardial cells has under the influence of sympathetic pathway or autonomic nervous system. The second influence what we have is that we know as calcium influx. In the previous segments, when we have discussed about the electromechanical coupling, about the translation of the electrical signals to mechanical signals, we have learned that it is the calcium influx during the plateau phase which is responsible for releasing of the intracellular calcium stores of sarcoplasmic reticulum. So similarly, the second effect of this influx of calcium is that we have stores of sarcoplasmic reticulum here, which is huge stores of calcium. So with the influx of calcium, the sarcoplasmic reticulum is stimulated to release these extra calcium into the cytosol. So the cell is now loaded with more and more cations. So these calcium is now available for the sarcomere unit which is there in the cell, which we have discussed yesterday. We have Z lines, then you have M line in the center, we have actin filaments, thin filaments, and then you have thick filaments which are myosin filaments, it has got myosin heads. Now we know that actin filaments do also have troponin proteins, like we have described in previous segments. Suppose this is the actin filament. You have myosin head binding sites over here in the actin filament. We have troponin molecule on the surface of actin filament, and this troponin molecule is also attached to tropomyosin protein, and this tropomyosin protein is arranged in such a way that it covers the myosin head attaching receptor sites on the actin filament. Now, as soon as the calcium influx happens into the cell, one effect is that we have an extrasystole, a bathymotropic effect, a triggered activity. The second effect is that it stimulates the intracellular sarcoplasmic reticulum to release more calciums into the cell, and now these calciums are available for the sarcomere unit for muscle contraction. So the calcium goes and attaches here to the troponin molecule, and under the influence of the calcium that is attached on the troponin, the myosin is pulled, and now the tropomyosin filament is pulled, and now the myosin head binding sites is now exposed. Under the influence of calcium, the myosin head binding sites on the actin filament is now exposed, and now the heads of myosin can freely attach to the myosin head binding site. And based on the sliding filament theory, we understand that there is shortening of the entire unit of sarcomere, which will be reflected in the muscle bundle as contraction of the muscle bundle. So this, when we have more amount of calcium available, there is more effective or more forceful muscle contraction which is taking place, and this is what is called as positive inotropic effect. So these are the two effects what we have on contractile myocardial cell under the influence of adrenergic pathway. Influence number one, it can cause triggered activity. It can cause triggered activity, which is called as bathymotropic effect in the contractile cell. And number two is that it can release more amount of calcium from the intracellular reserves of sarcoplasmic reticulum, so that more amount of calcium is available for the muscle contraction process, so that more effective contraction takes place, so the force of contraction increases, so that we have a positive inotropic effect. So positive inotropic effect and positive bathymotropic effect are the effects which we have under autonomic nervous system influence, specifically sympathetic nervous system influence in myocardial contractile cell. And in contrast, in specialized cell, under the influence of sympathetic activity, we have increased automaticity in SA node and also increased conductivity in AV node. And under the influence of M2 muscarinic receptors parasympathetic signal pathway, we have decreased automaticity or decreased heart rate in the SA nodal cells, and we have decreased conductivity in the AV nodal cell. So to sum up, we have positive chronotropic effect and positive chronotropic effect under the influence of sympathetic pathway in SA nodal cell, and negative chronotropic effect under the influence of parasympathetic pathway in SA nodal cell. Coming on to AV nodal cell, we have under the influence of sympathetic pathway in AV nodal cells, we have positive dromotropic effect, and under the influence of parasympathetic pathway in AV nodal cells, we have negative dromotropic effect. And coming to contractile myocardial cells, we only have sympathetic pathway here because ventricular myocardial cells are devoid of muscarinic receptors, M2 receptors. So we have sympathetic pathway running here, and this sympathetic pathway has got two effects. One is bathmotropic effect secondary to the triggered activity, and because of more available calcium for forceful muscle contraction, we also have positive inotropic effect. So with that, we are coming to the end of the series of lectures we had under the topic of cardiac electrophysiology. So under which we have discussed resting membrane potential. How is resting membrane potential generated in specialized myocardial cell and contractile myocardial cell. So we discussed generation of resting membrane potential in specialized myocardial cell and under contractile myocardial cell. We also discussed generation of action potential in both specialized myocardial cell and contractile myocardial cell. Then we discussed conduction of action potential along the membrane in specialized myocardial cell and in contractile myocardial cell. Then we have discussed electromechanical coupling, which is the translation of the electrical signals into mechanical effect, which is contraction of the sarcomere muscle and sarcomere unit of the muscle, and this we have discussed under contractile myocardial cell because special myocardial cell is not applicable. And last we have discussed the influence of autonomic nervous system in both specialized myocardial cell and in contractile myocardial cell. Now when we have discussed about the action potential, the conduction of action potential, we also discussed the different types of waveforms that we see in all these types of cells, in all the three varieties of specialized myocardium, both SA node, AV node and Purkinje cells, and also on the two varieties of contractile myocardium, which is atrial and ventricular contractile myocardium. So this is what we have summarized in the series of video lectures which we had on electrophysiology. Thanks for watching. Thank you so much.